Welcome, Professor Bright here, and our next segment of the course is going to look at factoring. And so we are going to look at a few different factoring strategies, and in the end, I'm just going to say, well, it's going to boil down to guess and check sometimes. But so that's going to be kind of the next segment of our course, and then we're going to use factoring to solve polynomial equations eventually. But the first strategy that we're going to look at with factoring is called greatest common factor, and then also grouping. But before that, I just want to clarify, why do we care about factoring? What is it, right? And so remember in math, we always want to be able to undo what we do, right? So if we have an equation where we have to add, it's like x plus 4, we want to be able to undo the plus 4 via subtraction. Factoring is the same thing. We just want to make sure that sometimes factoring, when we look at a factor, right? So like 3 and 4 are factors of 12, right? They multiply together to give us 12, so we would call 12 the product, and on the other side of the equation we would have the factors, right? So factors always multiply to give you a product. And so sometimes if we wanted to undo that, right, we could, do division to undo the multiplication. Well, when we have x's and y's and variables in general, it's not always possible to do division. Or if we do division, we might divide by 0 and then bad things happen. So same sort of thing here with the 2x squared, right? This would be our final product. And then the factors here would be 2x and then x plus 3. Okay, so that's the idea, is we want to break it into products and see, and then sometimes that form could be just as helpful to us as, say, the operation that we would do of division. All right, enough preamble. Let's get into the strategies. Greatest common factor. Idea is look at each term and see what is common and what are the common factors, and pull those common factors out in front. Okay, and so if you want to look at the book, I'll do it one way with the book that they do it, and then I'll show you just kind of how I do it. But they say, okay, let's look at each term individually and say, okay, this is 2 times 3. We're going to break it all the way down into the smallest units that we can, right? So 6 we can break into 2 times 3. Those are both prime numbers. And then y to the fourth would be, 4y's all multiplied together. Similarly, 18y squared, right? That'd be 2 times 9, right? But 9 is actually 3 times 3. And then we have 2 more y's. And then what they say in the book is, okay, what is common? Well, we have a 2 in common, we have a 3 in common, and then we have, 2 of these y's, doesn't matter which 2, in common. So then our GCF is going to be 2 times 3 times y, which is 6y squared. Okay, and then what we would do to finish this off would be to write the remaining factors from each of the terms. So from the 6y to the fourth, I'd have, y squared left. I inherit the sign, and then in the remaining piece, I'd have a 3. Okay, and so that's how I do it. That's how the book does it. And if you need to write it out visually, that's fine. Moving on to the next example, what I tend to do is I just kind of look at the numbers and say, okay, well, 70 is 7 times 10, right? And then 105, that might take a minute, but 105 ends up being 7 times 15, and then 14 is 2 times 7. So I'm thinking like there's 7 in common with everything, right? I could break this into primes, like this would be 2 times 5, and 15 would be 3 times 5, right? And then that doesn't really happen. So I think in terms of the numbers, right, there'd be a 7 in common with everything. And then I'm going to look at the variable expressions. There's x squared, a single x, and an x cubed. They all have at least one x in common. And then with the y's, I see y squared. They all have a single y. Okay, and so then when I think of factoring, I think of division, right? Except it isn't true division because we're not getting rid of it completely. We're just pulling it out in front. We're pulling out the greatest common factor. And so then what do we have left after I take the 7xy out? Well, I think I have the 10 and then x left in the first term. Second term, I take out the 7, I'd have 15, and I have the xy already out. And then from the last term, if I take a 7 out, I'd still have the 2. I have 2 x's, and I have 1 y left. Okay, and so Mine is maybe more of an advanced level, and it is virtually the same process, just shown a little bit differently. Okay. So whatever way works best for you, if you need to write out each of the factors and then identify common factors, please do that. The next strategy kind of uses factoring by, or greatest common factor in there, and it's called factoring by grouping. And the idea is that typically, when you look at a polynomial, you're going to have some terms that have common factors together and other terms that don't, right? And so what we're going to do is kind of chunk the ones that have common factors together, and then find the GCF, take that out. Okay. The only thing that I'm going to caution you with on this one is that you need at least four terms. I'm going to say at least. Okay. So you need four things to be able to do this. It doesn't work with three or less. Okay. So what we're going to do is chunk them first. So I'm going to chunk the first two, chunk the last two, and I look at those first two and I see they both have an x squared in common. These second two, they both have a 5 in common. And so when I do the greatest common factoring method among these first two, right, take out an x squared, I'm left with x minus 2. Inherit the sign, that follows down. And then out of these second two, 5x minus 10, take a 5 out of each of these, I'd be left with an x and another minus 2. All right. And then as I look at this, there's minus 2, or x minus 2 in common with both of those. So I'm going to say, okay, I can actually identify that as a common factor, and I can pull that out in front of everything. And after I take out the x minus 2, I'd have from the first term x squared plus 5. Okay, so that's factoring by grouping. Just to show you it again in another example, okay, generally you're going to chunk two terms at a time and then see what's common among each chunk. In this first chunk, let's see, I think there's a b in common, so if I pull the b back out, I'd have a plus 7. In the second chunk, 8a and 56, if I take out an 8, I'd have a plus 7. Oh, look at that. Okay. And so then the 7 plus, or the a plus 7s are in common, so that can come out in front. And then what's left over? B plus 8. Okay. And so that's another example exhibiting factoring by grouping strategy, right? And again, you need four terms for this. Now, if you do factoring and you're like, I'm not so confident in my answer, right? You can always do distribution, and I'll show it to you up here, right? You can redistribute and see if you get the same thing back. So 6y squared times y squared would give me 6y to the 4th, and then minus 18y squared. Is that what I started out with? Yeah. Yeah, so you can always redo the multiplication via distribution to check your answer and make sure that it is what you started out with. All right, so we have two factor strategies under our belt, a couple more coming down the pipeline here.